Generative AI can write an article, create an image, clone a voice, and generate a cinematic video. But behind that apparent magic is an uncomfortable engineering question. How much computing power should it take? The Atlantic recently called generative AI an engineering disaster, arguing that the industry has replaced efficient design with bigger models, more data centers, more memory, and more electricity. That may be too harsh, but what if the criticism contains an important warning? AI may be producing extraordinary results. The question is whether it can afford to keep producing them at the scale we are promising. The modern AI industry has been built around a straightforward discovery. Give a model more data, more parameters, and more computing power, and its performance often improves. That approach has produced remarkable systems. But the improvement does not continue at the same rate forever. As models become larger, each new gain can require substantially more computing, memory, electricity, and money. The industry may be pushing harder and harder to achieve smaller and smaller improvements. That is the brute force problem. And to understand why it becomes so costly, we have to look at the architecture doing the work. Instead of discovering a fundamentally better way for machines to learn, companies can continue building larger versions of the system that already works. It is expensive, but it may feel safer than betting everything on an entirely new architecture. Much of today's generative AI is based on the transformer architecture. Transformers use a process called attention, which allows a model to examine relationships between words, images, or other pieces of information. The hidden cost appears when the system must hold more information in mind at once. With standard self-attention, doubling the length of the material can require roughly 4 times the attention-related computation. That does not mean every operation grows at exactly that rate, but long conversations, large documents, and complicated sequences can become increasingly demanding. And filmmaking is built almost entirely from complicated sequences. A single image is one challenge. A moving image adds time. A scene adds continuity. A performance adds emotion, dialogue, movement, and interaction. A feature film adds thousands of creative decisions that must remain connected across perhaps 2 hours. AI filmmaking does not simply need to generate more pixels. It must remember what those pixels mean. And that is where a 10-second demonstration begins to collide with the demands of a 2-hour story. A film is not a collection of clips. It is a continuous memory. Today's AI video tools can produce remarkable moments, but a remarkable moment is not automatically a movie. A filmmaker may need multiple generations to get one usable shot. Then the character changes slightly, the costume changes, the lighting shifts, the performance loses its emotional direction. The camera does something unexpected. Every correction requires more computation. Now imagine asking the system for a longer scene, higher resolution, synchronized dialogue, multiple characters, precise camera movement, revisions, alternate performances, and consistency across an entire production. The promise is inexpensive filmmaking, but the process can become expensive through repetition. The generation may be cheap. Finding the correct generation may not be. That is why the engineering beneath these tools matters creatively. If every revision consumes additional credits, computing time, and energy, filmmakers may begin limiting their choices around what the machine can produce efficiently. At that point, the tool is no longer simply helping direct the movie. Its engineering limitations are directing the filmmaker. But that does not necessarily mean the technology has reached a dead end. I have spent 43 years watching new creative technologies arrive in forms that were expensive, awkward, unreliable, and occasionally maddening. Early nonlinear editing systems required specialized hardware and enormous investments to accomplish things a laptop can now do. Early computer graphics could take hours to render a frame that appears instantly today. Digital storage once seemed prohibitively expensive. The first version of a revolution is rarely the efficient version. It proves that something is possible. Then engineers spend years making it practical. Generative AI may be following that same pattern. What we are using today may not be the mature technology. It may be the enormous prototype, and the engineers are not standing still. Mixture of expert systems contain many specialized sections, but activate only some for each task. Smaller models can be trained for specific jobs instead of forcing one enormous model to do everything. Researchers are also developing architectures that process long sequences more efficiently than traditional attention. The search includes local AI, model compression, lower precision calculations, smarter caching, and systems that reserve the most expensive models for the hardest tasks. None of these approaches has completely solved the problem. Some introduce new complications. Others work well for particular tasks, but cannot yet replace the flexibility of a large general-purpose model. Still, they demonstrate that today's engineering is not the only possible engineering. The transformer may dominate this stage of AI. That does not mean it will dominate forever. The architecture that launched the current AI boom may not be the architecture that makes it sustainable. The next major competition in artificial intelligence may not be about which company has the largest model. It may be about which company can produce the same result using less. Less electricity, less memory, less water for cooling, less waiting, and less money. For filmmakers, that could matter more than another impressive demonstration. A model that creates a beautiful 10-second clip is interesting. A model that gives a director control, consistency, revision, and feature-length memory at a sustainable price could transform the industry. That may require AI systems that understand the structure of a production, a character model that remembers the character, a performance system that follows emotional intention, a virtual environment that remains stable between shots, and specialized tools that cooperate rather than one enormous model attempting to generate everything. The future may look less like one machine making a movie and more like a coordinated digital production crew. The best AI may not be the biggest. It may be the most efficient. Calling generative AI an engineering disaster makes a powerful headline, but it may confuse an unfinished technology with a failed one. The current approach consumes enormous resources, and the pressure to keep scaling what already works could discourage more radical research. Those concerns should not be dismissed as anti-technology. Engineering criticism is part of how technology improves. The greater danger would be pretending efficiency does not matter, because investors are still willing to finance inefficiency. Generative AI does not need to remain this resource-intensive forever, but it also will not become sustainable through optimism alone. Someone must build a better system. And when that happens, the most important AI breakthrough may not be a model that creates something we have never seen before. It may be a model that creates what we can already make using 1/10 the resources. So, is generative AI built wrong? Or are we looking at the first workable architecture rather than the final one? That distinction matters, because if this is the final architecture, the costs may eventually limit the revolution. But if this is only the beginning, today's inefficient systems may be remembered the way we remember room-sized computers and overnight renders, not as failures, as the machines that showed us what needed to be invented next. What do you think? Is generative AI fundamentally too inefficient? Or are we judging an emerging technology before engineers have had time to redesign it? Let me know in the comments. If this episode got you thinking, subscribe, because this conversation is just getting started. For more in-depth writing about AI, Hollywood, creativity, and the future of filmmaking, visit politicsofai.substack.com. I'm Mark Kimball. This is the Politics of AI Filmmaking.